Hello, I am UC Patnaik. Let us try today to analyze the inverter circuits in the internet. There are a large number of inverter circuits we will find on the internet, and we will see as to which one would be the best and which have the drawbacks. For example, in the heading here we find referring to about circuit diagram, then voltage, high voltage and high power, then certain wattages and wiring, welding, and then some ICs and we find several circuits here. So now let's try to first take a circuit up. Now once we take a circuit of this nature, what we notice that this particular circuit has some transistors which are 3055, 2N3055 and some tip 122. Tip 122 is a Darlington transistor. This is the Darlington transistor used to drive these 3055 transistors in parallel, and this is very old and obsolete circuit because 3055, 2N3055 has got a lot of drawbacks as far as its V saturation is concerned, and moreover there is a resistance in series, so there is a lot of power loss here. Because in bipolar transistor you have got to make some parallel arrangement. For bipolar transistors, if you are paralleling, you need to connect some series resistance in their emitter. So in the process there will be a power loss here also, and power loss here also based on the V saturation. If the V saturation is roughly about 1 volt, so for example, if the 50 ampere is divided by these two, so about 25 ampere will be flowing through this, and 25 ampere into 1 volt is 25 watts across this transistor itself. The dissipation will be, and plus if it is 0.1 ohms, and then you can multiply and then find out how much power loss will be here also. So overall the circuit is not good, though it uses a digital IC for this is the resistance value, variable resistance, and this is the capacitor to set the frequency, and once the frequency is set, this is going to be operating at that frequency. This is Q and Q bar. But serious drawback, serious mistake in the circuit is from 12 volt is connected directly a 9.1 volt Zener diode. It will immediately fail the moment to switch on because there is no series resistance connected here. So there are like that, the people only publish circuit diagrams without going practically into the application. So this is what the most of the circuits that we find which happens in the internet. Now let's take another circuit. Let's take a MOSFET circuit. This is a MOSFET circuit where we have again a R and C arrangement where we adjust the frequency, and we have the Q bar here which is directly feeding into the gate of the MOSFET. The biggest advantage compared to the bipolar transistor, MOSFET, that you don't need current, you need just a voltage, so it can give that kind of voltage here to switch on this. And this is a half bridge arrangement where this MOSFET operates for half cycle, this MOSFET operates for the other half cycle, and that is how this is comparatively a acceptable circuit. It is not a very good circuit, but compared to like acceptable circuit because it doesn't have, it has not taken care of any overload, it has not taken care of any voltage to be controlled. Now if the battery voltage varies based on the time application, based on the use, and the output voltage will also vary. There is no control arrangements given for this. So this kind of circuit is just okay for certain hobbyist type of arrangement, but it is not advisable to make it on a commercial application. And moreover, the transistor used here is RF540. RF540 has a very high RDS, so the losses will be very high here. Instead, somebody could really use Z44 or BUZ11. These are better transistors, MOSFETs compared to this. So this is the drawback of this particular circuit. Now let's take some other circuit, like let's take a circuit of this nature. He is using a 555 timer. A 555 timer where, and then again certain Darlington transistors, that too complementary, and there is a capacitor in series, and the entire current, imagine the entire current is passing through this capacitor. So the capacitor life will be very low and very poor. So this is never a, and R and C is of course is adjustable. This is a 555 timer which is in the astable mode. In the astable mode it gives square wave pulses, and those square wave pulses are delivering this. So far, in fact, whatever we have discussed, they are all square wave inverters. They are never sine wave inverters. So in the internet, actually, you will not find free sine wave circuit because they are in fact pretty expensive, and they are proprietary circuit diagrams, so you will not get them here. Let's see another circuit. Here is a circuit where he has used two batteries in series, that is 24 volts and 555 timer again, and driving the MOSFET. One in and then one side is made inverted and the other side is made direct. This is given direct and this is given through certain inverter arrangement, and that is how the 555 timer is given here. But then he has parallel the MOSFETs. These MOSFETs are parallel. MOSFET paralleling without any series resistance is okay. And then the transistor or the MOSFET that we use here, if it is Z44, then the losses also will be very low. Because of the losses very low, this circuit is apparently an acceptable circuit. It also doesn't have any overload or any voltage control. So this is also not to be practically useful as far as the commercial application is concerned. Let's see somebody using a SG3525. SG3525 circuits are comparatively better circuits because there you have the advantage, like for example this circuit. Let us take the example of this circuit. In this circuit, what is done here, he has taken a feedback from the output. And in the process, this feedback is rectified and a DC voltage is fed to control pin of the IC. In the process, the output is stabilized because based on the load, the output voltage will change. Based on the battery voltage, the output also will change. So it takes care of that by adjusting the pulse width. And of course, the R and C is the arrangement for the frequency setting, and these are certain other arrangements for certain protection. And so this is fairly a good circuit as compared to all other circuits that we have discussed so far. So it is better that one follows this circuit. Now, let us see another very practical circuit. Let's talk about these circuits. What we find here, there are two MOSFETs, Z44. You can parallel more numbers if you so like, because paralleling is not a problem. It's about 150 watts. It talks about 250 watts to 5000 watts. You can follow by just increasing the number of MOSFETs, and the rest all remain same. This has got comparatively much control voltage, although all are square wave, because they are never sine wave, they are all square wave. So some kind of rounding of the edges are made by these arrangement of this resistance and capacitance. So it is something like modified square wave, apparently tending towards sine wave. So it is definitely much better than the pure square wave. The biggest advantage that with another transformer, this is the main transformer, with another transformer, the voltage is fed from here to here, and a control voltage is again given to the sense point of the IC. This is between 1 and 2, there is a comparator, and the comparator is maintained at point number 2 is maintained at 5 volts, and over the point number 16 is 5 volts, which is maintained at 5 volts, and in the sense it changes based on the adjustment you can do. So the output can be controlled. Even if the load changes or the battery voltage changes, the output remains constant. So it is recommended that this circuit should be followed if someone is trying to make a good inverter. Well, this much is for the day for the inverters. We'll continue with few more circuits on different products, on different items, and if you feel it's good, please subscribe. Thank you.